context. Basic stuff.
Yeah, thank you, Felix, and thank you to organizers for inviting me for this keynote speech. So I would like to start with what I would like to do today is kind of try to talk more about the terrestrial networks, and as well, I think, in my opinion, very big importance in DTN development. And let's see, this. I think the problem is this is covering the. Let's see if I can do this. Okay. So my background is a bit different probably than most of the audience here. So it's like in the last 15 years, I've been focusing on DTN, but I never really done any space-related projects. So it's actually, I'm sharing a bit of different background. And this is one of the latest projects that we concluded last year, and it's we've done actually DTN-based. We built a DTN-based network for tracking reindeer up in northern part of Sweden. So it's basically entire system that is built. It's kind of so we have a application that actually is able to work completely off grid. Actually, so if you have internet connectivity, you will download things from the server, but otherwise you just basically rely on the DTN network. And you can actually use the Bluetooth on your phone to connect to we call them pocket nodes, which is basically the interface between the LoRa network, LoRa radio network, and the mobile phone. This is one of the base stations on one of the top of the mountains. It actually can run for 2 years just on battery life. Otherwise, the entire system is solar powered. We're getting quite a decent radio links up to 80, 100 kilometers on this peak. So it's quite a calm because due to the national parks, it's basically we don't have any mass and no radio interferences. So we actually get quite a clean spectrum to actually use. This is how, if you're launching rockets, I mean, within the space industry, we're connecting everything to the snowmobiles and pulling it up to the mountains. So it's like, we usually do this during the winter time, where you can actually drag these things up. I mean, otherwise during summer, we need to basically hire the helicopters and fly them up. Most often the maintenance is done during summer. So, and that's actually, during that time we use helicopters only. And it's hard to access once it's deployed. So I think that's again, one of the similarity with the things that space industry does as well. I would like quickly to return like 15 years ago when we've done the M4C project up in the mountains as well. So what we've done during that time, we actually we deployed DTN in some of the remote villages, and we actually provide some basic connectivity. It was the HTTP caching. Podcast during that time was still popular. So it's like during that time, there was no cloud infrastructure was not the thing yet. So it's like it was possible to offload the data and actually push it through the network. We used the Wi-Fi connectivity instead of, because I mean, the latest project was really narrowband, long range. During that time, we used Wi-Fi, so it was wide bandwidth, but really short range. We used the helicopter flights that were coming into these villages once, twice per day. So you could actually offload the data. And yeah, again, like everything was kind of powered with the solar power. There's basically due to the national park policies, it's actually area probably like 200 by 200 kilometers. There's no roads, no power infrastructure, no radio infrastructure. So it's actually quite a particular place to actually test DTN. And I think I'm bringing this up because of two reasons. I mean, first one is like I was kind of forced to spend 3 summers up there for 1 month. So it's like I have to say you get pretty isolated. And during that time, I mean, my only link to the world was actually bundled protocol. During that time, we used the BPv6. It was, I think, DTN2 implementation. We used the Prophet for routing. So it was different time. And I think it really kind of gives you experience, like, I mean, it's like how it is to actually have no IP connectivity, because it's quite often like in this audience, I mean, it's like yesterday I heard like, if it doesn't work, we just use the IP connectivity and it solves many problems. But when you're up there, you need to think differently. Like it's like, and you get 2 hops. I mean, it's like, so basically, you get 2 connection opportunities per day. So it's, that's how we basically done it. And the second reason why I want to put this to kind of put it into the context of time. So it's actually, this was 15 years ago. And I have to say during that time, I think the DTN was really seen as one of the ultimate solutions, going to solve everything. And if someone told me during that, after 15 years during that time, we'll have if I could choose whether we'll have a driving cars or fully deployed DTN, I would vote for DTN. So it's like, and we have self-driving cars instead. And so I think we all share in this room the vision of the interplanetary DTN. And I actually tried to Google just DTN and interplanetary internet and just see what kind of images come. So these are the images from NASA, ESA, and JAXA. And it's like, and I think what's interesting is like in this is that I think it's one vital piece that it's missing in these images. And I think it's actually terrestrial nodes. I think we need to grow. We need to build more terrestrial based DTNs. So what we're missing is actually missing kind of quite a big industry partners, I guess, that could really leverage from the DTN connectivity. And one is surely agricultural. Like, I mean, it's like been just last year, I mean, kind of talked with some farmers in northern UK, and I think they have still problem. They have problems with updating their tractors, the problems to kind of download the software. They cannot do their crops because of this. And it's like they're connected, but it's not always there. So it's kind of we have world still that kind of lacks the connectivity. Then we have mining industry that I think one of the potential future partner for the space industry. It's kind of quite big. Logistic and maritime. So I think that's again like one of the things that could be really leveraging. Then we have kind of disaster war situations. I mean, for instance, the forest industry, like that's something that I'm kind of familiar in northern Sweden. Like, they often, when they're in this forest, despite the Sweden is quite well covered, like you have still, when you drive these machines in remote areas, in some deep valleys, you lose the connectivity. It's actually something normal. So, and I think lastly, as there's many research here, like I think just the research industry, I mean, research kind of, I think they could really leverage for maybe some sort of DTN standardized data collection. So it's like during the M4C project was actually one, I think quite a good experience that and experiment that we've done actually is like one company in Sweden was kind of dealing with the meteorological stations. They actually implemented the USB stick kind of a CLA. So everything was automated. So they have a station that was really remote, and actually was one person every day that plugged in the stick into one of these machines, put it into the mail, it's like mail it with a normal mail, and then when it was collected, they just plug it in. What was amazing with that, it's like the end side of this is like when the data was analyzed and processed, that was all automated. So it's like you basically didn't have to do anything. So you basically just literally plugging in and out stick. So it's like I see that I think it's when it comes to like for instance like Swedish Polar Research Institute, they have a lot of these remote places that I think can as well leverage from the. So why does this matter? Like for non-space industry, I would say it's kind of missing opportunity for more robust and reliable communication. So I think and I think the second point that I think it's, at least in my opinion, kind of became quite big actually is that actually DTNs really, really help us to do the really low power off-grid application. As like, for instance, in the case that we have up in the mountains, like most of the nodes that are deployed, they're basically in sleep mode, like probably 95% of the time. You don't need to listen, you don't need to have radios on, you don't need to, because radios, just listening to radios takes a lot of power. So it's, and I think in current situation, I think with the current, like this micro satellites actually and the connectivity that kind of is in the polar orbits that comes up like 1 sparks per day. I think it's really like good combination that can actually really, really drive the remote off-grid application. Then lastly, it's like, I think it's a really large market. It's like it can have an immense impact, I think, on a development of DTN. So I think if you just get like 1 or 2 partners in like either mining industry or forest industry, I think it could really push DTN much further. For the space industry, I guess this is something that you probably know matters. It's kind of the economical model is changing. So it's we see more commercialization, more commercial partners that are not maybe so familiar with the space communication. They will need basically some stack as well to use it that can actually that can actually later on seamless integrate with the other industries. And as well, just to access the hardened off-the-shelf based DTN-based solution. And I think this is where Terrestrial could make some impact. And this is like maybe I'm kind of want to share as well my personal experience, that trying to adopt DTN. So I own a small company that's actually developed underwater buoys for measuring the ice thickness using the sonar and pressure sensors. And this buoy is kind of running LoRa radios on it. So it's kind of usually 2 meters underwater. It's then picked up, signals then picked up by the base station, and then actually I want to kind of process and show this to my users. one of my goals was actually to do everything over the bundle protocol. And one of the reasons, like I want to, label all my products with a BPv7 ready sticker. And unfortunately, so far, I failed. I have to say, I think there are still some missing pieces. I think we still need to work on a couple of things. And I would like to actually go into them. So that's kind of my opinion. It's like, so what are we still missing? So I think it's like we could probably do more robust and flexible DTN implementation. I have to say that when I'm using the DTN in a way that was envisioned, I mean, I have to, most often, like I don't have any troubles. But as soon as you start to, bring some unexpected conditions into the test, I think things do tend to break, they get stuck. So I think that's where we can probably do better. And especially when, I mean, this applies, I would say, for the bundle storage management, I think we need to focus a bit more, as this is the store and forward protocol. I think we could probably do better with, for instance, try to make more adaptable bundle storage that, if you have bigger resource, I mean, more resources, you can actually maybe store more bundles, smaller. So just adopt that when you reach and as well, maybe start to throw older bundles away if it gets, if you're not able to kind of deliver. And so I think we can do a lot of things like, so different forward strategies that could really, really help in, I would say, like probably space, but as well terrestrial application. I mean, I think I still kind of want to have a kind of portable DTN stack for mobile platform, because I mean, it's like what I wanted to do basically to use I want to kind of give users mobile phone and mobile phone applications they're going to use bundle protocol. So far, I think I'm not aware that any of them would be easy to port. I might be wrong. So it's like, in the group, it's what we're trying to do now is actually, we actually dragged one really old Profit implementation we've done and actually applied the bundle protocol to it. So we've done some successful demonstration already of that. So hopefully we'll have, as it's written in Qt, it's quite easy to basically port to the mobile platform. And I think this future implementation, I think what I mean with that is that I think it's this table that Mark actually did. It's like when you look at the implementation, when you look at the CLAs, when you look at the features, it's really, sometimes it's quite hard. You need to pick one thing. You cannot have it all. And I think it's really a problem. Like you find a perfect candidate for maybe your application, but it will not have certain convergence lights, and then you need to implement that. So it's kind of really a bit of like a puzzle how to actually, to kind of go forward with. And then this is, I think, something I really like to maybe discuss more with. It's like, I mean, I think we need to be better with, handling the bundle time when it arrives when we process. So the assumption that every DTN node will have an atomic clock, I think it's really, really not acceptable. I think it's often when you talk with people, I mean, they kind of just pre-assume. And I think it's like, as soon as you and then you don't need to go to space, and bring the relative theories. I think it's enough just to use different time zones or just badly behave, systems like, and you will end up this. So it's like, I think we can implement, I mean, it's something I feel like we can actually easily fix. So we can just implement more sanity checks, give them a bit more tolerances, maybe check, it's like if you're all getting bundles that are 1 hour ahead or behind, maybe just assume, okay, this is actually still a valid bundle, but it's like, so I'm just kind of proposing that there's probably things that we could better. And as well, I mean, ensure that proper handling of bundles with zero timestamps, like especially in a sensor network, you will not have maybe system time available. So it's like, that's something when I was kind of checking maybe a year or two ago, and I've seen that many, implementation didn't really implement the zero time and the sequence numbers, right? So, or many, I will say, there are not so many places. So, what are we still missing? I think one thing that, we work a lot in the IP and SIG group is actually getting the DTN run over the carrier grade nets and net. So it's like as soon as you're behind the firewall, it's actually quite hard to actually connect to that node. And I think I'm actually wondering, it's like I think what I would propose to actually make some more IP friendly CLA that would be used probably mainly for terrestrial application that would actually allow, for instance, if client connects to it, you establish automatically bi-directional connection from where you can. So basically don't need to do the port forwarding and all these things that it's quite hard to do for the average user that's not familiar with networking. That's the next point I guess we will address tomorrow, develop a common model for building DTN application. I don't know, like sometimes I'm a bit skeptical, if we need the API, surely we would all benefit, and especially if we would have it common and implement over the different. But I think one thing that maybe we can actually learn as well from the LoRaWAN kind of project is to maybe we just need to standardize bundled payloads I don't, at this point, it would be probably, I mean, maybe enough. It's like, and as well, I think it's lesson learned as well. I mean, while working with the distributed, application, it's actually doing the distributed application. It's quite hard. I mean, that's something that I experienced with the project with the raining curves, where we actually had the functionality to send, messages. It gets very complicated very fast because, you have users, you have like, and how to distribute then the user base, and it's like all these things. And I think it's something that we need to probably practice more. Just, MQTT as well, it's one of the services that I would like to implement over the BP, because I think we could actually integrate so many already existent platforms, especially from the LoRaWAN projects. And then adopt more applications to bundle protocol. I think it's like most often I think especially recently in the mailing list, like, I mean, we hear more that we're adopting, sometimes I feel like we're adopting more the bundle protocol. I mean, what I wanted to say with this is I think sometimes there's just simply no way around. We just need to kind of maybe rewrite the application. We need to rewrite the service instead of actually try to tweak IP. I mean, and we have some dark forces in that corner that I will not mention. That actually, I mean, we might find some other ways, but I think it's something that as well we could do better. And then I think the last thing, I think this thing that I feel like I'm missing is like, just like that industry would probably need, like, so we need some sort of operational terrestrial DTN network that we can actually all kind of join and start to use. I think it's crucial for developing and testing of the DTN, and even more essential for securing and immunizing DTN. I think like most of the DTN's implementations, they're running behind really strict firewalls. And I think I'm just wondering, like what's going to happen in future? Like, I mean, it's like, let's say we get more and more industries in it that will require the access to these networks. I mean, it's like eventually we'll have some security breaches. So I think it's better to do it now. It's better to do it in terrestrial application when, if things go wrong, it's not as bad as if things go wrong in space. And it's like, I would like to share like one thing that we've done in the IPN6 project working group. I mean, it's like, so we actually start to build the kind of the first generation of this network. Was it like 2 years ago, I think? And we came basically up to probably 20, 40 nodes, maybe even more, like, but depending like, and it was a globally spread. It was, I think, cover many continents. I don't know if it was not all, surely not all, but.
Not all, but yeah.
Yeah. So it was really impressive. Like, but we quite quickly, hit the scalability issues. Like, so, I mean, and especially how to manage contact graph once, you pull one node from the network. I mean, how to update this with the rest of the client. So basically we had to all, gather all together, reconfigure our nodes, and then try it again. And we ended up with star mesh topology. So basically all the traffic that we've done, all the experience that we've done was basically over the one hop, which as well, I think, and as well, the services we ran was, just basic, just experiments and tests. So it's like not real load on traffic. So, and I think just last week I kind of started, and I start to push within the group the new generation of this operational network. And the idea here is to kind of is based on the so-called DTNX. I mean, it's kind of a contact graph exchange mechanism for DTN. And I think the idea here is that DTN comes in many varieties, and it's going to be hard to find, one solution, one routing foreign solution for all. So it's kind of we kind of just dump them and go the other way. We wanted to basically check what's the smallest common denominator of all these DTNs, and that's basically, you could say, the contact. And the idea is here is like, the idea is here is to standardize contact as a, let's say, bundle payload, and then you basically simply exchange your contact that you have with, and the contacts that you want with the neighbors. And send all this thing over the BP. So here again, like, I mean, I wanted to first, I mean, I'm really pushing in this in the project working group that we need to use and start to use bundle protocol more. So I mean, entire this prototype and everything runs over the BP. So how DTN works at the moment? So it's like, so it lists the local plan and contacts that you have on your node. So it checks basically in line. Currently, it's implemented only in Ion. It basically checks the index and outdex, and then it shares these contacts you share it with your neighbors. It's quite a simple step. And then when you receive this, you basically parse them again, like using just the BP sync command. So it's like no need to compile or anything. You update your local contact graph plan and then forward it to all the nodes except the one that you receive it from. And then optionally, you can actually contact. I mean, so you get the listed contact graph, or you can actually create the image. And this kind of runs in constant loop that kind of updates every minute or whatever time that you set up. So current implementation is actually implemented in Bash. It's kind of really unusual, but I want to do it in this stage. So basically, I want that, it's easier for users. They don't need to recompile Ion. They can just start this as a Bash script, run it somewhere in the background, and it's going to do everything automatically when the Ion is started. So, and in order to do this, it has embedded watchdogs. You don't need to, do any extra configuration. And then this contacts can then spread over the update and spread over the network asynchronously. So every time when they expire or new contacts emerges, it just sends it and shares with the neighbor. I actually added a pre-shared key just to get some sort of basic contact integrity and to prevent, but mainly to prevent the network loops. So it's actually, you store the local hash of all the messages that you got, and then you just kind of avoid processing messages that you already received. And it actually brings some sort of, integrity. Although, surely, I'm not a security expert, so I'm kind of waiting for this to be hacked in the future. So, but so far, I think it kind of works. So and then next step will be, I wanted to integrate it as well with the micro 3DTN, and I wanted to integrate it with the AGTN so we can actually start to grow a network. And then later on, implement it in C and, add it to the Ion. Kind of fun fact that I kind of figured out when I was doing this, it's like when I talked with Scott Burley, it's like this is already integrated in Ion. For me, it was really an Easter egg, and it's a service called, I always forget the name. Yeah. So but for that, the reason why, it's like I didn't propose this to use it in group is actually for that you need multicast, and that's done only in Ion and not other implementation. And I really want this network to consist of different implementation at this stage. So maybe later on we can actually do it differently. Just how this contact looks like. So currently it's basically sent over the plain text. I want to do this later on with the CBOR, so we actually save some place. I will plan to kind of work on the internet draft if this gets more adopted. And this is basically just the current format of the exchange. So it's basically just you have a hash, you have basically the version type, you have basically what this message is within this DTNX. Then have expiration time, origin of this message, and then you have basically node the node that you receive it from, and then you have a node A, node B, and then optionally you can actually as well like maybe start time or data rate or anything that you want to. And this is how currently after 1 week how network looks like. So this is the link that you can actually open. You can follow up. How this will emerge like so. This is actually updated every minute. So this contact graph is now kind of rendered to one of this central node, but later on this will be, probably I want to do it a couple of places to avoid the single point failure, and actually then maybe compare this contact graph. So it's like, this is done kind of automatically on the fly. So if one of these nodes gets removed, I think it's going to be updated after 1 hour. It's just going to basically show it's going to disconnect it. So it's going to be interesting to see how this grows. Here's some links. So the code is free to use on a GitHub. And as well, this is the link how to join our project working group. We haven't yet. So I would really like to invite everyone who's interested to join. We have basically the main policy is you just need to introduce yourself and then as well say how you would like to contribute to it. So, but it's open for everyone. Thank you.
So for me, you've mentioned a lot of interesting points to discuss, but are there questions from the audience?
Yeah, excuse me, I saw a lot of considered question about bugs. Whatever happened to IDRs? It's an Android implementation that we all put on our Android phones.
Yeah.
So there was some. We did an Android implementation, and IBR did an Android implementation.
I can tell you a little bit of history on that. The reason is because we tried to update it. And the challenge of building mobile applications is not exclusive to Contact Protocol tool, but to primarily any corporate application that has a long lifetime, is that mobile standards, operating systems, and stuff change much quicker than our development timeframes. So, for example, by the moment we try to update the applications, the application wouldn't work on any of the existing Android frameworks. So we had to pretty much be said, hey, we're not going to do it. There is no, it's just too much effort. So that's an ongoing challenge, which is, okay, if you commit to build an application, make sure that you have budget, bandwidth, so that 18 months later, 24 months later, you have to massively update it so that it connects to the new stuff. That's the biggest.
There's different implementations.
Upload, yeah,
Android,
yeah.
iPhone.
Yeah.
Is SamiNet still a thing?
You mean no, it's actually not at the moment. So it's like, I mean, it's possible to basically this network that we have up there. It's possible to simply plug in if you have use the UART CLI. It's simply you can plug it into base station and actually run. You can send the bundles over it. So it's kind of a, but so it's possible to use for our application than just tracking reindeers. Yeah.
So you were mentioning, maybe you have more applications. So do you have something in mind that is like the killer app or
Yeah, I mean, it's like we talked about it like 15 years ago as well. I don't think so, but I think it's like maybe at this point is, I surely think that MQTT would be one of the really, really useful and practical because there you can run so many things. You have like chats, you have like, I mean, entire IoT is built on it. So I think MQTT would be, in my opinion, quite a strong application, but surely I wouldn't say there's a killer app or.
Just to add, we have had some work on MQTT for bundle protocols. So I'm point you to that and put you
okay.
So there might be something out already. Yeah. Any additional questions? Big question? Yeah.
Thanks for the great presentation. I think it's very important to have a standard way to exchange contact plans. Do you have thoughts on opportunistic contacts? So do you plan to support like distributing information about dynamically discovered contacts?
Yeah, I think it can be easily added as in already now. I mean, it's like, I'm adding this meta information. So for instance, in order to render this graph, I mean, it's like all these nodes can have, carry some meta information. So it is possible to expand it. So, but I would like to keep this as simple as possible. So basically, because as soon as it gets complicated, and I think the contact is like, but it is possible to add it. So.
Thank you. Let's thank our speaker again.